once again, good afternoon to all. With a warm welcome, I wish to introduce today's speaker, Professor Neema Ukani ma'am. She is industry expert of industrial robotics and automation. She has 15 plus years experience in industrial robotics. She was working as industrial robotics department head for last 7 years at Nagpur University, and now she is founding member of NU Intelligence Pvt, Nagpur. She has pursued MSc degree in industrial robotics and automation from Germany, and currently pursuing her PhD in machine learning based smart agricultural irrigation at lovely professional university. She has published 20 plus research papers in robotics, machine learning, embedded system and IoT domains in various national and international science journals. As well as she has published her paper in IEEE conferences. She has keen interest in research and development in robotics, automation and data science. Now I would like to call K.D.K ma'am to please do the welcome by offering her sample. Welcome ma'am. Now I would like to call our head and convener, coordinator of the Atal FDP, Dr. S.P. ma'am, to present her memento as a token of love. Now I request Professor Neema Ukani ma'am to please start the session.
Okay, good afternoon everybody.
Good afternoon.
I think I am audible to all of you? Yes. Okay, so we'll start our session. So we'll take a couple of introduction of brief of what are the topics we are going to learn, and we will start with a super basic thing. I am sure that it is going on from couple of days, so you can just get a little bit revision of that. I have divided this session into first we will take brief about it, simple introduction, then we will go forward with a hands-on activity with the SVM, right? So in a simple, if we talk about, no. if we simple talk about that, what is SVM, that is your support vector machine system. So SVM were originally proposed. Okay. Okay. You want voice into that? So SVM were originally proposed by Bosler, Guyon and Wapnick in 1992 and gained increasing popularity into late 1990s. It means that he has started the journey in 1992. Before that, there were a couple of algorithms were initiated and people were using it and everything. But from 1992 it was introduced, and after that the various different kind of problem statements have been solved with this particular algorithm. So it's important aspect of machine learning, as we are knowing very well. So SVM are, you can say, support vector machines. So we will go forward with that. This is a machine learning technique. So we can also call it as a black box technique. So we are considering white box technique and black box techniques. So white box technique is generally defined as the technique where we know what is happening exactly parameter by parameter inside your algorithm, how the output you are getting, what are the parameters you are passing, and all the mathematical descriptively all the things are very clear to the person who is using it or the developer who are using it. Black box technique is something where couple of parameters are hidden, couple of things which are already being done into the software itself. It's not it's not very clear to the developer, but though there are prepared library and classes and subclasses, though the developer has not used or have not created that classes, subclasses, but they are using it. So many of the time you can say many of the applications which are being used in real time, so you can consider it as a black box system where developer doesn't know exactly how it is going to react algorithm wise. So that's why it is called the black box technique. So data separation of non-linear classes are done using the kernel tricks. So we will take consideration that what is SVM, then what are the types of SVM, why the kernel is being used, everything slowly steadily we will go forward with that. So whenever you are using or whenever you are learning any new algorithm, there is a tuning process which is happening it is very one of the crucial process which is happening after you are splitting the data and all, after that process. So we will see what are the tuning parameters and tuning techniques available in SVM. In simple, a very basic thing if we go forward with, we can say there is a three major, you can say distinguishing or separating or classifying the machine learning with supervised machine learning, unsupervised machine learning and the reinforcement learning. In that, if you see the supervised learning, we are having two groups. We can say classifier and next is the regression. In that, you can consider that SVM, that is your support vector system, it is using both the groups itself. So simple definition wise, again we will see a pure definition where whoever has introduced the terms and all. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. It means you don't need to heavily program your algorithm, but there are again classes, subclasses, some kind of methods which are there which you can use in order to do some particular task. So that is a definition which is Arthur Samuel given in 1959. So there were people were using machine learning, deep learning, a lot of things more than 50 years, but the computational power has been developed from last 20 years. It has been developed vastly, and people community wise, people are using, or due to the data generation, people are more and more using the machine learning, deep learning and in general data science. That's why the growth is very rapid into last 20 years. Specifically we can say after 2000 the growth is very fast. Next is the computer program is said to be learned from the experience capital E with respect to some task T and some performance measure P. So if its performance on T is measured by the P improves the experience of E. That is the definition from Tom Mitchell 1997. In simple language, if you want to see, machine learning is something which is imitating the human behavior in broader, in general layman language. If you want to see that if being a human being, we know that we are over here available, like we are sitting over here attending something. So we know that we have seen each other, the faces and everything we have seen. So later on, any point of time, if we meet, we will have that memory stored into our brain that okay, we have met this person or we have interacted with this person. But if you want your machine to remember those things, where you have to see the face recognition techniques and everything is being used, where the machine is remembering the features of a person, facial features of the person, that is one way to take forward with that. Another thing is, in many of the countries and the states in China, they are also taking blood samples of people, as well as the way the DNA is being stored into China in such a way that if somehow you're participating into some activities which you should not participate, so into that they have stored the DNA, and they can recognize by walking or speaking or in general your pictures, they can recognize that whether this person is abiding citizen or the law citizen, or you can say it is following the rules or it is not following the rules. So a lot of algorithms are also used globally. Next is, what is supervised learning? So when we were born, we were not aware of recognizing this is apple or this is a different kind of fruit or this is watermelon or something. But by passing time, we labeled this is apple, this is watermelon, this is like XYZ car or bicycle or something like that. So we labeled that kind of thing. So we have supervised and we labeled that this is, if any category of any object which comes into this category, it is has to be apple or any fruit or any automobile or something like that. So we can say presence of data and associated labels for the data is defined as the, you can say, supervised machine learning, where you are using a simple equation y is equal to f of x, where it forms the foundation of the supervised learning itself. So the input variable is x over here, while it is the output variable is y. So you are passing the input variable, so f of x is equal to y, or y is equal to f of x, you can consider it that way. So mapping the output as a function of input variable, whatever you are sharing with that. It can be one label, it can be multiple label, depending on what complexity of system you are working on. How you can classify the supervised machine learning? There are two different ways you can classify. One is the regression, the second one is the classification. So these are two particular subgroup of supervised machine learning, where this regression is something, because you have labeled the data, the machine will recognize it from the past data, so it can do the prediction of the future values from the past data. Second is the regression, where you have used categorized of the items that you have used, means the data is available, so you are doing the categorization of items by using some data in that. Next one is the unsupervised learning. It is exactly opposite of supervised learning. It means that you are not putting any label into any kind of data. So now your goal will be to find out what kind of structure or features which are available into your data itself. So that is your unsupervised machine learning, where you are passing the data without telling the system that this is apple or car or something like that. The system has to identify that and it can be used in that. So there are two kinds of grouping systems into that. One is the clustering, one is the association. So clustering is something which is a grouping of input variable with similar characteristic, that is, you can consider it as a clustering. Second one is the association. Association is something which is mapping association based on the data. So whenever we are talking about association, feature association or suggestive association is one of the widely used phenomena globally. So you talk about any OTT platform, any kind of search you do into your OTT platform, whether you like a sci-fi movie or you like maybe a thriller or crime drama or anything, it will keep giving you suggestions, right? So it is giving you it is associating with the kind of entry you are passing it with your whatever values you are passing, whatever prompt or key features you are passing or key values you are passing, that you want, like Hollywood movie or comedy movie or anything like that. It keeps you giving the suggestions. Similar way, we are very much aware of that the Google and like in general, if you are sharing or if you are putting any suggestion, not suggestion, but if you are searching anything on Google, it will give you, later on whenever you are searching anything elsewhere, you get the pop-up of the different advertisement of the same kind of product or something. So there are also suggestive association is happening into that particular background. Next one is the reinforcement learning. Reinforcement learning is something, if anybody is having pets, if you're doing the training of the pets, where you're having you can say you are training the pet with, you're giving some reward and you're giving some punishment, that kind of, in layman language you can say. So if a student, hypothetically speaking, if the student has passed or if the student has scored up to like distinction, your college is going to give the, celebrating the, that particular victory, or the parents are also celebrating. So that's a reward. If a student has failed into the examination, then parents are going to tell the student that you have to learn more and more into the domain. It means you have to work harder. So that is not, it could be a punishment, or you can also say the suggestion also into that to improvise that. So for training purpose, you're training the dog or that kind of application, you can use it. Reinforcement learning is very, very widely used into many of the applications, starting from automated various kind of robots. I'll give you one example, that if I have a robot like a small kitchen robot and I want a robot to flip the pancake or flip the omelette, something like that. So that is one time it is flipping the omelette, but after like one time you are flipping the omelette, it means that you need some kind of pressure and power, and what is the way of movement that you are using with your robot itself. It's going to be one of the most difficult tasks, right? That you're flipping it, because it has to be mastered. So you have to have multiple iteration of a robot to learn how to flip it. Second example I can give, if you're aware about the humanoid robots, we have a company Honda. From there we have a robot named Asimo, and it was working more than 20 years. The research and development happened. It is one of the finest walking robot that we can see in currently. They have stopped the production of that. It was a purely research and development. Right now they have not manufacturing that. So to walk a robot like a human-like robot, to walk the robot, to maintain the center of gravity and everything. So it's an iteration, it's a reinforcement learning. You check that whether the motor is properly working into the feedback loop or not, and that way, so a lot of reinforcement learning is being used into the many kind of robots. Then you're having natural language processing. Now natural language processing is widely used into speech to text conversion, as well as any chatbot applications. Many of the chatbot applications you talk about, from Alexa to Siri to, if you want to develop a chatbot, you have to use the NLP very heavily in that. Marketing and advertising, it is used. Image processing, it is being used. So this is reinforcement learning, where your data is saved and your data is improvising. Every single iteration, it gets better and better. Now I have purchased Alexa in the year of, for an example, if I'm not wrong, 2016. So that was around like first prototype of the Alexa at that time. I purchased for the research purpose and to check that what is the robot now, how it is, coordinating with the speech, with the dialect and everything, how it is communicating. So I have developed in 2016, wanted to connect with the robot and industrial robot and do a lot of research work into that. So at that time, the library and everything was available into the English language only. Now if you see the Alexa, if you buy the Alexa, you have multiple language, and it works so beautifully in so many languages. It understands the dialect very well. It understands what you're trying to, it can be a sarcastic at some point of time if you say, tell me a joke or sing me a song or I am bored or something. So the sarcastic, that flavor has been added into that. So it's been years of thing, the reinforcement learning, and even the NLP works better and better as you give the more and more input into that. I'm sure 2016, there will be only thousands of users, and if you compare it with the current date, it's been more than like 8-7 years. Many, it will be into millions of users of Alexa. So more and more data has been input in that, and more robust the algorithm is going to be. Then the recommend system, gaming system is using a lot of reinforcement learning, energy conservation, then traffic control and all. So here we are using the SVM. So SVM is one of the most important into machine learning, very flexible, working with a variety of the data. Now again, if we are talking about data, we have structured data, we have unstructured data, we have semi-structured data. Structured data is something, your Excel sheet, you can say it's a structured data. Unstructured data is something where you have some images or you have some videos or something. Semi-structured data is your Aadhaar card. I'm sure nobody's having good picture on Aadhaar card. I don't have a good picture on Aadhaar card only. So it consists of one picture, then a lot of data is there, some code is there, right? So it's an unstructured data. Example, that driving license for an example. So those are unstructured data we are having example. Now overfitting is very less compared to the other models. So we will also see what is overfitting, what is underfitting, how we can recover from overfitting, underfitting and all. So here we are having training time is more if the data set is large. It is but obvious that it is connected with the like training data. If your training data is a small amount of data, it takes less amount of computational time to give you the output in terms of accuracy at the end of the algorithm execution. If your data set is very large, say for an example, we are going to use that either 1000 pictures of a cat and 1000 pictures of a dog. 1000 plus 1000, 2000 pictures of data set if we are using, and we have to recognize that okay, this is the picture is a dog picture or a cat picture, right? That we can use by using SVM also. So if we are recognizing into that particular, we can do it into the KNN also, and a couple of other different CNN also. We can use that algorithm on that kind of problem statement. So if you are having large data set, computation will be more. It will take more and more in time to execute and give you the prediction and forecasting. It's very popular in healthcare and banking sector itself. So now the terms that we are taking, that is overfitting and underfitting. Can somebody tell me what is overfitting and underfitting? If you have any other information that what I am sharing over here, what is overfitting?
If the data is very complex, then the algorithm may not be trained properly and the results may not be accurately there. Prediction results may not be accurately.
Okay. Anybody else? Underfitting, overfitting in any algorithm? Okay.
Data plots go from the outliner region of the predicted value, then it is overfitting. If it is under going less than the predicted value, that is underfitting.
Okay. So we can consider it that way. We are very much aware of that. So overfitting is a machine learning behavior that occurs when the model is too closely aligned to the training data and that does not know how to respond to the new data. So that you can define it as a overfitting. So how it is happening, why it is happening, if your data is very complex, if you are using multiple, like a heavy data if you are using. So the machine learning model is too complex. If your model is too complex, it means that if you have multiple parameters that you are working on that particular model, maybe feature extraction and something like that. Your model is very heavy and it's very complex. So it memorizes very subtle patterns in the training data that it don't generalize it very well into that particular, right? So that you can say where the overfitting is happening. Another thing is training data size is too small. If the training data size is very small, maybe a very small amount of data you are passing into your algorithm or you are giving as an input into your algorithm, sometimes that can also lead to the overfitting issue. So the training data is too small for the model complexity, or it contains large amount of irrelevant information into your data passing. So if you are passing data, sometimes it happens that many of the null values are passed or some blank values are also passed or something like that. So you are not very sure that whether the data you have shared or you have applied to the algorithm is the clean data or not. You need to have pre-processing, and many of the a lot of data engineering you have to do into that particular time. So you can prevent overfitting by managing model complexity and improving the training data set also into that. So that we can say that's a overfitting. If you compare it with the underfitting, so we'll see how it does. So in underfitting, it's exactly the opposite of that underfitting, that the model doesn't align well with the training data or generalize well to the new data which we are passing into that particular. So overfitting and underfitting can be present both into two groups of classification as well as regression. It means any algorithm you use into machine learning, like for that matter, or even go forward with the subset of deep learning and that, it is going to happen because you are dealing with the data itself. So here we are talking about a simple illustration of that. that you are having overfitting, underfitting, and you can say the right fit. Now if you are checking the dots which are like blue color dot and the red color dot, so you have two partition into that. So in the first we can see that though it is a very non-linear distribution of the data into the first, so here it is happening which is overfitting. Overfitting, it means that it is too good to be true in simple terms. ऐसा होता ही नहीं है. It is too good to be true. If you are doing or any machine is giving you that kind of output, that's a red flag. You have to see that whether something is getting wrong into that. So overfitting is that kind of criteria. Next one is the right fit. Right fit is something where manageable. It is giving you a little bit permission of like mixing the two different classification, a little bit data into the red dot side, a little bit into the blue dot side. Underfitting is something where too much of data is at both the sides. So it means that it's not a very good prediction, or the output wise, the output is not which you desire as a developer in that. Similar fashion, so one is into the classification we have seen, and second one is the regression. So both the examples you can see as a data wise over here. So if you want to overcome into that, we are having couple of techniques that you can overcome. So we can say that when we are looking forward to the computational or computed error of a machine learning model for the training data, overfitting is very harder to detect than the underfitting itself, because you're very optimistic being a developer and you think that you get 0.98 or 0.90 something accuracy into your model. Somehow you don't realize that that is not the real the way the model is reacting in that. So here, to avoid the overfitting, it's important to validate a machine learning model before you apply the machine learning model into any kind of test data. So this is one of the most debatable topic in the domain of machine learning and deep learning. What kind of data and which kind of model has to be used. So you will see a lot of research going on into this domain, that if this is one kind of data, and if you really are interested into that, you can do also, you can check some other research paper and see that if you have any kind of structured data, what model has to be implemented into that to get the better result, because there is no need to reinvent the wheel. If people have already done the research, you have to read that research and you can add more into that particular time. So next one is to prevent the overfitting. You can do model validation. That is one of the term, or they can do to overcome the overfitting and underfitting. So here you are saying for overfitting you can do model validation. So error of our overfitted model is low when computed for the training data. It's good to predict the valid your model on a separate data set. So it's a validated of data set before introducing to the new data set. So that is one particular way you can save it. Second is the regularization. So you can use the regularization, various techniques available in order to overcome from that. You can also do cross validation as well as you can also use the regularization too. For overfitting, how you can enhancing the training set. Whatever training data you are giving it to you, how you can enhance that. So to overcome from that, either you can do some artificial data to be created and you can use that. So that is data augmentation. Data augmentation is something where the data availability is limited. So your data set is a small data set, and data augmentation is a method where artificially you can expand the data points of the training data set by adding randomized versions of the existing data to the current data set. So one is data augmentation that can be done. Next one is data generation. So you can also use some algorithm to generate the data in order to club it with the existing data set. So synthetic data generation is another method to expand the data set. One can generate synthetic data by using generative adversarial network, or GAN, you can abbreviation of that, or you can use digital twins data generation through simulation. You can also use it, random data generation. Next is the data cleanup. So if any kind of blank data, if you are having into your structured or non-structured data where you can fill up that data, so that is also something we can work on. So that is data cleanup can be used. Now data noise. noisiness contributes to overfitting. If your data is noisy, it means your data, you have a lot of garbage available into that or wrong data entry available into that. So it is also one common approach to reduce undesired data points, to remove outliners from your data itself, right? So that is also, data cleanup is one of the part you can work on. So here what are the application of SVM, which is support vector machine? So one is the face detection method. It can be used in face detection, text and hypertext categorization, classification of images, like you're classifying that this is like what class it belongs to. If it's like an animal data set, that you have 40 different animals data set is available, so this is like a cat or dog or caterpillar or elephant, or so there is classification of images you can work. Bioinformatics it can be worked, or it can use facial expression classification. So many of the apps are also, or many of the applications are also developed into, depending on, like I have seen the experiment when one country was developing one application, there was a headset connected with the like a camera system into that, where it checks that what kind of emotions are on person's face the person is studying. It means what is the concentration level and the facial expression of a person where the person is studying. So if you having like 8 hours of session, say for example 10 to 6 in between like lunch break or something, how the person is having the concentration level during 8 hours of time, then how your brain is responding to the information which is passed to you. So that kind of also one of the application can be like used. So facial expression classification, it can be used. Speech recognition technique is used in that. SVM is used in that. Cancer diagnosis and prognosis, it is being used into that particular application. Handwritten recognition system, it can be used. Now handwritten recognition system, many of the algorithms are already being used into that. So that particular application it can be used. Protein fold and remote homology detection, it can be used. Then generalized predictive control, GPC, that is also being used into that. Now in simple SVM, if we say support vector machines, so here you are having a simple, I will take a simple diagram of that. We will take a simple basic information about SVM, and then if it will be needed, we will go into the mathematical intuition into that, or we can skip that part also. So the goal of SVM algorithm is to create best line, or you can say the best fit line in the distribution side. So we can say that SVM is a classification and regression, both the application or both the categories you can use the SVM. So the goal of SVM supports is to create the best line or the decision boundary that can segregate n-dimensional space into classes, so that we can easily put the new data point in the correct category in the future. So you can say there is one perfectly fit line or best fit line, you can call into, like in SVM terminology, you call it as a hyperplane. So hyperplane is dividing two different data, one class and the another class, or two categories or two features. Anyway you can like understand in that. So SVM chooses the extreme points vectors that can help in creating hyperplane, and these extreme cases are called as a support vectors, hence the algorithm is also named as a support vector machines. So you have a 3 lines into that. The center line you can consider the plane, like if it is 2D you can consider is as the hyperplane. There is one line which is you can consider is as a support vector. So if we see over here a simple diagram of that, you have the data set into, you have a left, like there is one particular, right, you have square and dots. So you have categorized the data into two sides. So here you are having intermediate, you have a maximum margin, or you can say there is a maximum margin hyperplane is available, and the dotted line you are saying that is the data maximum, or you can say the extreme, the data is available into that line. Those data we can call, or those lines are, we can call it as a support vector line. So these are the dotted lines available here. I'm not sure if I can show my mouse here. Yes. So this line you can say as a support vector, where the extreme is this data is available or lying on this particular line, as well as this is also hyperplane, but this is also support vector. But here this side of the section is called as the negative hyperplane, upper side of this is called as the positive hyperplane, and intermediate that is hyperplane, and in the section itself is called the maximum margin itself. So this is a very ideal case where you have a data set and you have a proper distribution of one negative hyperplane or one positive hyperplane, in between you have hyperplane. This is an ideal situation. Usually doesn't, in real life, in real data set, it doesn't happen like this. In real data set there will be a mixing, right? So some data point could be nearby into negative hyperplane, some data could be into the positive hyperplane. If you have this kind of structure, you can call it as a soft margin. There will be noise available into that plane also. There will be not a maximum margin available with like a purely distinguish both the margins. So that will be, in that case, that will happen. Say for an example, if you are using two feature only, so you have again maybe 1000 pictures of a cat and 1000 picture of a dog itself. So you have a dog and cat data. So you use the dog and cat data, you train your module. Again, it depends on what exactly, how much test and training data you want to. Usually it splits between 70-30, 80-20 most of the time. Very rarely it will go with the 90-10, but most of the time is 70-30 and 80-20. Right? 70 would be the test training data, and 20% or 30% would be the test data that you are having. After that you do the prediction, you give the unknown picture to your algorithm, and it will predict that the feature is similar, either the features are similar to the cat or the features are similar to the dog, and at the output it will predict that it is cat or it is a dog. We can also do it with similar way, you can also do it with the car or bike or something like that. That is also something we can check. So we are having two kinds of SVM available. One is the linear SVM, second is the non-linear SVM. Right? So linear SVM, it is used to linearly separate the data, where it means that the data set can be classified into two classes, which is like you have two features, you can distinguish into two classes by using a single straight line. You can say it's a hyperplane, you can divide it, and such data is termed as a linearly separated data, and classifier, it is used as the linear SVM classifier. Second one is, you can say it as a non-linear SVM. So in non-linear SVM, so you are having data set which cannot be classified by using the straight line, right? So this kind of data set is termed as a non-linear data set, and you can use the classifier with that. We can call it as SVM classifier, or sometimes it is also called as SVC. Okay, that's the like support vector classifier. Sometimes it is also called that particular thing. So hyperplane and support vector in SVM algorithms can be multiplied lines and decisions boundaries to segregate the classes in n-dimensional space. So here it comes with the, either it is a 2D space or 3D space, depends on what number of like features you are extracting and the classification you are doing. So here we can multiply, so we can say that okay, there is one particular line, perfect hyperline. But what if you have multiple linear lines? How we can judge that this is the best fit line or this is the only hyperplane into that? So next we will see that the SVM algorithm, so data points or vectors which are closest to the hyperplane. So you have a hyperplane in between, so whatever data points which are closest to that and which affect the position of hyperplane, we can term as the support vector. As the dotted line on with the dotted line, you can say it's as a support vector. And this vector supports the hyperplane, you can say it's a support vector. So this is simply, you have this category, you have one set of data and another set of data over here. So the working of SVM algorithm can be understood by using like simple this example, that suppose we have a blue dots and green dots available. So you have two feature of your data set, say for an example x1 and x2 into that. Now here by looking at the picture over here, it is very like simple to see that we can make multiple linear lines into that. It's not just only one linear line you can like, you know, right, you can distinguish, you can use multiple lines into that. So if you see here, It can be like a straight line that way, it can be like a slope kind of line or the slant line that way only. But we have to take care, you have to see that what is the distance between these two support vectors. We want the distance between two support vectors, the dotted lines, as long or as large as possible. Which line we are talking about? This line. So we want the distance between this support vector, we want to maximize the margin. The whole algorithm is based on that data should be as distant with each other, as distant as possible, hypothetically speaking. So in between that, if you are having any lines which are giving you the maximum distance between this support vector and this support vector, if you are having maximized margin in between you are getting by your calculation, those hyperplane and support vectors are considered for your calculation. So though you have multiple linear lines in between that, but the line support vector in between, if you have maximum distance between these support vectors, the main aim, or you can say the motive of this particular algorithm is something that the support vector should be as distant as possible. If it is as distant as possible, that is the motive we have, and if we are not getting it, like we have to maximize the distance. In between, what are the mathematical calculations are coming? What is the permissible, what are the permissible values which we are having for the prediction and accuracy? So those details we will see into that. So here the SVM algorithm that helps to find the best line and decision boundary, that is the best boundary or the region is called as the hyperplane. So this is the center one, this is your hyperplane, and here this is your best, you can say the maximum distance from the hyperplane that you are having for the support vector lying on that, and you are increasing or the maximize the margin in between these two support vectors available here. So SVM algorithm finds the closest point of the line, both the classes, that are points are closed as the support vectors, and the distance between the vectors and the hyperplane is called as the margin. So this distance is called as the margin itself. So you have hard margin, you can say soft margin. Hard margin is something where you don't have any other intersection, or you can say the data is very nicely categorized between two plane, but there is no green spot here or green data here or blue data available over here. If some of the green data available at this side or on the plane of the support vector, and some of the blue data is available on support vector plane, so we can call it as a soft margin. And here if it doesn't occur, so you can say this is a margin, or you can say maximized margin that we are trying to use or we are trying to create into our application. So that is that was the linear SVM. For non-linear, you are having more amount of like data available which is not clearly, you cannot distinguish, you cannot use two categories into that, you cannot participate, like you cannot divide into two different sites. So here what is happening, if you are having data which looks like this, where you cannot like draw any kind of hyperplane, right? It's very difficult to see that whether we cannot even imagine here we can make any kind of hyperplane into this particular category. In this category we can imagine that we can create the hyperplane distinguishing two data into two different sites, but here we cannot see that any kind of hyperplane can be created into that. So if we having non-linear data, if data is linearly arranged, then it is fine, we can separate it by using straight line. But if the data is not linearly available or arranged, if non-linear data is available, then we cannot write or we cannot draw the perfect hyperplane into that. So we are considering in this application, we are adding one more, you can say axis into that will be your z axis you are adding. Now up to this it was only x and y plane. So on x and y plane you are categorizing that this side and this side. Now if you have non-linear data, you have to imagine that you have a xyz plane now. So now it is into 3D, that if you are having this kind of x, y and z, and if your data distributed into this particular fashion, into that, now you can distinguish or now you can categorize that this is a plane where you can have one data in one side or one data feature at one side and one data feature at the other side itself. So you have to add the z-axis into that. Similar way, if you are having data into like this non-linear data and you are having this 3D space. So into this 3D space, if you are looking at it that right now that the plane is for the x-axis, y-axis and z-axis. If you see over that, for here to convert it into the 2D space, you can say if the value of z is equal to 1, then this will become, it's really hard to imagine into that, but that will be into 3D where you will get this kind of output into that. Now what are the different terminology available with the SVM? So one we call it as a signal. So what is the meaning of signal into the that we use into the terminology? So it refers to the true underlying pattern of the data which helps a machine learning model to learn from its own data. Next is the noise. What is noise available into your data? So noise is something which is actually not a part of data, which is irrelevant data, right? Noise is, the definition of noise is something unwanted signal, right? The signal is not wanted, that is unwanted signal. So that particular, say for an example, any kind of noise you are having into your data, so noise is unnecessarily or irrelevant data that reduces the performance of the model. Now why it is reducing the performance of the model? Because it misguides the developer. If the developer is using that data, it misguides the developer that this is a good prediction, whatever output you are getting. But in reality, it may happen that it is not working the way your developer is actually aiming for. So noise is something which is unnecessarily or irrelevant data which can reduce the performance of the model itself. So that is noise. Next one is bias. Bias is a prediction error that is introduced in the model due to oversimplifying in the machine learning algorithm, or it is also difference between the predicted values and actual values. If you are having it is difference between like predicted and actual values, you can say that is a biased output, or you can say that's an error. Next is the variance. So if the machine learning model performs well with the training data set, if the machine learning algorithm is working well with the training data set, but it doesn't work well with the test data set. Now again we are having a split of the data like 70-30, 70 is training, 30 is say test data. So training data it gives you the better result, but for the if you are doing the test, it gives you the unpredictable or not desirable result into that. So that is, you can say that's a variance which occurs into your particular algorithm execution. So these are the terms that we have already seen, so we can even revise these terms. So hyperplane is nothing, you can say it's a like a simple line. If you are like talk about the 2D, simple mathematics, if you say y is equal to mx plus c, you can define it y is equal to mx plus c, a simple line for that matter. Here you are defining it as wx plus b is equal to 0. So into that you have one side which is a positive side, positive hyperplane, one side which is a negative hyperplane. So you are defining it that way with best fit line and with the hyperplane itself. So y is equal to mx plus c, you are representing this as wx plus b is equal to c. That is a hyperplane equation you are having in this. So what is hyperplane? It is nothing but the decision boundary. It is a decision boundary perfect fit line that is used to separate the data points of different classes. So you have like green dot data and blue dot data. You are distinguishing the two classes of data. It can be two features, you are separating them. So here they separate the data points of different classes in a feature space. In case of linear classification, it will be the linear equation that will be wx plus b is equal to 0. It's very simple, it's not that complicated also into this. And even though mathematical wise, it's simple that whatever mathematical steps and whatever mathematics going on into SVM is perfectly fine. But being a user, being a developer, you are actually using a scikit library. So your already developed libraries, you are using it. So here you need a little bit brief to know about it, else the library will take care of that. Support vectors, again the closest data point to the hyperplane. closest data point to the hyperplane is defined as the support vectors. So support vectors are the closest data points to the hyperplane, which makes a critical role into deciding the hyperplane and the margin itself. So that is the support vectors. Margin is again the distance from both the support vector, right? Aligned with that center you have a hyperplane. So margin is that we want the margin has to be as large as, or we are maximizing the margin as much as possible for our algorithm. So margin is the distance between support vector and the hyperplane itself. And the main objective of the support vector machine algorithm is to maximize the margin. So this is the key feature over here, that I will again go forward with the diagram here. This one. So we require a simple thing. A minute. Yes. So this is your margin, right? Your maximum margin that you're getting here. Here your negative hyperplane, this is your positive hyperplane, this side is your positive hyperplane, this side is your negative hyperplane, and this is your maximum margin hyperplane. This section is called the margin, and you want that margin to be as broader as possible. That's what we are doing into our algorithm, right? In simple terms, हम ये कोशिश कर रहे हैं कि डेटा जितना ज़्यादा दूर आइडेंटिफाई हम कर पाए, उतना हमारे अल्गोरिदम के प्रिडिक्शन और फोरकास्टिंग के लिए अच्छा है. जितना नज़दीक आने की कोशिश करेंगे, हमको बहुत मेहनत लगेगी उसको वापस सेपरेट करने के लिए. तो जितना ज़्यादा मार्जिन होगा, उतना ज़्यादा वो परफॉर्मेंस अच्छा आपके अल्गोरिदम का मिलेगा आपको. So in the next term we can see what is the term here, margin. So this is the thing, that what is margin? Margin is nothing but the distance between the support vector and the hyperplane. And the main objective of the support vector machine algorithm is to maximize the margin, and the wider the margin indicates the better classification performance of your algorithm. The next is the kernel. So kernel is the mathematic function that is used in SVM to map the original input data points into high dimensional feature spaces, so that the hyperplane can be easily found out even if the data points are not linearly separable. So again we are having two types of SVM method. One is the linear SVM method, one is the non-linear SVM method. For the non-linear SVM method, we can use a different kind of kernel tricks to classify the different categories, or you can say to classify the features into that. So the hyperplane can be easily found not even if the data points are not linearly separable into the original input space. So some of the kernel functions that can be used, again the kernel is being used to tune the parameter. हम कोशिश ये कर रहे हैं कि मैक्सिमम मार्जिन हमको मिले हमारे SVM एल्गोरिदम में. अगर हमको नहीं मिल रहा है तो हम कर्नल उसमें, अगर 3D आपका एप्लीकेशन है या 3D स्पेस में आप क्लासिफिकेशन करने की कोशिश कर रहे हैं, सो यू कैन यूज द कर्नल ट्रिक्स टू सी द ट्यूनिंग, टू ट्यून योर डेटा सेट और टू डू द क्लासिफिकेशन अप. So here we are having kernel. Most common kernel functions are linear, polynomial, radial, or it is very famous as RBF, radial basis function, and sigmoid. These are the kernel functions which are being used with the SVM algorithm. Next we can say hard margin. So what is hard margin? So hard margin is the maximum margin hyperplane, or hard margin hyperplane is the hyperplane that you can say properly separates all the data points of different categories without any misclassification. So it means that one side of, like blue dots are available into one side, green dots are available, data points are available at one side only, they don't mix with each other. So that is hard margin. Soft margin is something that when the data is not perfectly separable. I'm sorry, are you writing? Shall I like go back here? Done? Oh. So next is soft margin. So soft margin is the data is not perfectly separable, or it contains the outliers. So here you are having data which are almost mixing with each other and you cannot define the hyperplane in between. So when the data is not perfectly separable or contains the outliers, SVM permits a soft margin technique. So here at the soft margin technique, it says that each data point has a slack variable introduced by the soft margin SVM in formulation. We usually call it as a C. Right? So it discovers a compromise between increasing the margin and reducing the violation. It means that how much mixing of the data in between the hyperplane is permissible or allowed, right? So that we can call it into that. Yeah. Next is the C. Margin maximization and misclassification finds are balanced by the regularization parameter. We call it as a C into SVM. So the penalty for going over the margin or misclassifying the data items is decided by it. A stricter penalty is imposed with a greater value of C, so which results in a smaller margin. It perhaps the fewer misclassification in that. Next is the loss. So loss function is also one of the primarily or very widely used function into maximum of the various kind of categories of machine learning algorithm. In SVM, you are defining a loss function. You can call it as a hinge loss. So hinge loss is something, it's a loss function. In SVM it is used and it punishes incorrect classification. So you have again hyperplane, blue dot data, green dot data. So here if you are having misclassification into that, so it punishes the incorrect classification or margin violations, and the objective function in SVM is frequently formed by comparing with the regularization term. Next one is again the common phenomena which is happening into SVM. We call it as double formulation. You can also call it as a dual problem. So what is dual problem? So it is, you can say, a dual problem of optimization problem that requires the locating the Lagrange multipliers related to the support vectors can be used to solve SVM. Now if you are using 3D, space into your SVM, into 3D space you have to use Lagrangian functions where you are trying to do the classification, right? That will be you are classifying the data in two different categories as well. So here the dual formulation enables the use of kernel tricks and it gives you more effective computing at the output itself. Now we will see a little bit mathematics of that. These are just purely list of equations into that. So here we are again using V transform x plus b is equal to 0. Again a simple hyperplane can be defined is W transform x plus b is equal to 0. In that W is the weight factor, x is the input factor, x is the input vector, W is the, here we are having weight vector, and b is the bias. So if you are categorizing your hyperplane, here you can say this is your hyperplane which is defined as W transform x plus b is equal to 0. One side it goes like negative hyperplane, this side goes like positive hyperplane, and if you define it by the function f of x is equal to sine W transform x plus b. So this is a simple way you can mathematically represent the SVM algorithm into this. Now how do we know that this is the best fit? Again the best fit line, right? That whether it could be many best fit line. So it could be multiple lines which can be, you can like, there is no uniformity into that. You can like different ways you can try to plot into that. So the basic thing is we have to see that maximum, you are getting the maximum margin in between your support vectors. You have to see that how many data lies onto negative hyperplane, how many is lying into the positive, which are the nearest into that hyperplane. The distance should be as high as possible into that. So here you are defining it, the value of distance from the example x of I to the separator is, so here you are having the distance r is equal to W transform xi plus b divided by mod w. So here w is defined by you're having a magnitude and the vector also into this. So you're defining here the distance, the margin which is rho of the separator is the distance between the support vectors. That's how you are defining it. So next one is you are trying to see the value of rho, the margin. It has to be as large as, maximizing the margin, it should be as large as possible. So you are trying to do it into your calculation. Next one is the linear SVM. You can say mathematically. So you are using here W transport xi plus b is less than or equal to minus rho by 2 if y of I is equal to minus 1, or if y of I is equal to 1, you are having two category, less than, equal to, minus value, greater than or equal to positive value y, because you are categorizing into the positive hyperplane and to the negative hyperplane. So you are getting the distance here and your hyperplane output you are getting here. The margin can be expressed through the rescale W value. So you can say rho is equal to 2R, 2 divided by W over here.
But can we have an hands-on this particular thing is only totally theoretical?
We can skip the theoretical part and we can start with the hands-on, right? Okay, fine. Let's go with the hands-on over here. I would need to share some data. So how can I share the data? Maybe some data set if I want to share. How would I do it?
You have the WhatsApp group there.
I have WhatsApp, sir.
Rightly, it is present in your laptop.
Not now. Can I disconnect this for a moment? Sir, I can. Give me a second.
त्यांचं डेटा सेट नेमकं कसं आहे ते application based
Jupyter notebook.
Anaconda.
So in your desktop you can open a notebook, fresh notebook, and we will start the hands-on on that. Yes, sir. Give me anybody's phone number. I can share the data with. Or Khandet ma'am, you want? Okay, you can just share me the hi on WhatsApp.
Is it downloadable? You can download from
Jupyter download.
data set.
Yeah, but again, it will take time. It is modified also. Couple of things are modified, so I can share. That way we can go a little faster in that. Okay, I will share the data here.
इसमें Jupyter तो नहीं है इसमें है तो Jupyter Anaconda
Search for Anaconda first.
No problem, sir. Please do. I have one data set which I have shared. Let me share more data set.
Google.
Okay. I guess every participants are part of WhatsApp group. I am sharing shared database on it.
Sir, you have two data set. One is the user data, one is the social network ads. Just add the another data set also. You can share that also.
नहीं कर तो एक पे कर लेते हैं.
Two data sets I have already shared on FTP WhatsApp group.
तो मेरा ये स्विच ऑफ हो गया. मैं भेज दूँगी. नहीं अभी अभी तो अच्छा अभी करने के लिए.
Yes, sir. As of now.
ऊपर वाला खोलो. मैंने करना पड़ेगा. नहीं खोलो. नहीं फिर मत. शॉर्टकट बनाते हुए शॉर्टकट चलते हैं उनको. ऑस्ट्रेलिया से सर. नागपुर है. नागपुर के बाजू में दिल्ली. ये दिख रहा है K.D.K कॉलेज. सर देखो किसका सीटेट चाहते हो उनको दो. चालू हो गया. नहीं चालू हुआ.
Sir, can you help here?
फुल्ली लाइटेड दिख रहा है ऊपर से कर
You are not getting detected.
तो नीचे में ग्रीन वाला वहाँ से चालू होता है.
I can use the.
मेल पे भेजूँ क्या मैं? मेल ओपन करो ना. स्विच स्विच ऑफ हो गया. नहीं इसमें ओपन करो. भेजो. हाँ मेल में डेटा सेट भेजता हूँ. हाँ भेजो भेजो.
I try to do it. So we can go forward with the first example. Now I am not sure is it visible to all of you or not. Just let me know if it is visible.
Please share the
Sorry ma'am?
online keyboard so that we can copy from.
You want me to
So,
soft copy of all this? Are you sure?
it will take time to type it.
Okay sir, yes sir, you were saying something.
If you wish to share this code, you can use online
Online
clipboard. Online clipboard.
Again sir, we will do one thing.
One tab you require to open and just Google it online clipboard. That's it.
There we can paste and
I'll be comfortable for WhatsApp because it's on the channel, if it's okay with you. No? Okay, online you want to?
Just open a one tab.
Hmm.
Google it online clipboard. Online clipboard.
Clipboard?
Yes. Click me. Click. 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 Just the very first one.
Okay.
Copy the code. Paste it here only.
Okay, but sir, I have multiple cells.
Yes, that's the issue.
Multiple cells. We'll do one thing. I'll give you a better option. We'll give one thing. I'll share it with you. You just download. You guys can open your WhatsApp in your desktop, right? As of now, you already opened it, na? So just upload it into your. That will be better, faster. I will. I will share it in the WhatsApp, so they can download and upload, and we'll be happy. I will take one by one the code and then, yeah? Okay. Sorry, ma'am?
they are very bright students.
Not doubting that, ma'am. At all. Not questioning that. Okay. Just give me, sir, 5 minutes. We'll do one thing. Okay, so you have a data set, just upload into your Jupyter notebook. We'll share 4 or 5 files. Again, upload it. Few files are also, do we have internet also, sir? I think into all this. So they are connected with the internet. So from the Kaggle, they are directly opening the files and data set and all. So just give me a few minutes.
Then can you open this in Colab and share it so that we can...
I already have it into my editor itself, like a local machine I have it. So I was not aware of that, otherwise I would have come prepared in that. My apologies. Just give me 5 minutes.
डेटाबेस थोड़ा ज़्यादा है क्या?
Yes, sir.
आपने एक फाइल शेयर किया.
Uh-huh. That is Excel file, CSV file, sir. वहाँ पे.
सोशल नेटवर्क.
वो भी CSV file है. वो small amount, it's very small data set, sir.
No, our files are looking same. User and social.
हाँ वही ये देखिए ये.
They are looking the same. I have seen all the values, and these values are almost same.
Sir, then use it.
Use it better.
I haven't checked both that way, sir, so I'm not. Maybe it is reused with the other way also. Might be the possibility. I haven't checked line by line, sir. So.
नहीं CSV हाँ कॉमन सेपरेटर नहीं है CSV और दूसरा खोलिए मैं दूसरा भी भेजा आपको मेल ओपन करिए उसको मिनिमाइज कर दीजिए दूसरा मेल खोलिए दूसरा मेल खोलिए एक और बार वो करिए रिफ्रेश करिए ये जो है ना घुमाओ ना ऐसा राउंड घुमाओ ना सर
take a 5 minutes break and you do that thing, you upload in WhatsApp.
Sure, sir. No problem, sir.
We can have tea break. You can ask us.
स्टूडेंट दो तो ऐसा होना चाहिए कि इट्स द फाइट फॉर एवरीवन नॉट
Sir, I am very cooperative faculty. You take 15 minutes of break. I won't mind.
As much as you want. एक बार और कर लेते हैं। एक बार आगे मुश्किल से। चाहिए नहीं मिला। हाय। है ना? करने से कुछ बुरा भी नहीं। तीनों बार वही क्यों बोल रहे थे? वही आया फिर से। यूजर डेटाबेस भेजना है अभी तो ये सोशल नेटवर्क ही आया अभी फिर से करेंगे। ये देखो वही आया था सोशल नेटवर्क वाला ही है तो बोल रहा है इतना भी बहुत सारी फाइल जमा होंगी फिर वाजिस नाम से देखो वाजिस नाम से भेजता हूँ मैं ये भेज रहा है देखो ये अगर सोशल नेटवर्क ही आया दिक्कत है ना वही आ रहा है ये है ना सर ये है अगले सप्ताह में नहीं हमें से रहेगा ना हमें से ऐसे तो इंडेक्सिंग में हट जाएगा और पेपर भी हट जाएगा
Sir, I have shared you. I have shared files, data set, PPT with you, sir. In your WhatsApp, you can share it with everybody.
पानी चाहिए सर पेपर रहेंगे ना तुम्हारे को पीएचडी के पेपर ही चाहिए बस वही चाहिए उसको थोड़ी कोई इंडेक्सिंग तुम्हारे पेपर इंडेक्सिंग या ऑथर इंडेक्सिंग होना वो थोड़ी नहीं पेपर रहने चाहिए बस रहेंगे ना रहेगा बात पूछ लेता तुम्हारा यूनिवर्सिटी से नकली से भी चाहिए नहीं ग्वालियर से ये तो कुछ भी चलता है नहीं चलता इसको कुछ बोलेगा
So we will start whenever you will download and upload the files. And whenever you are ready, you can start. You can take your time.
इसको अपने को अपलोड करना है क्या इसमें कैसे करना है
सर ये आपका जुपिटर नोटबुक है ना,
उसमें हमने कर दिया फिर
यहाँ पे आप अपलोड जब करेंगे
ये कोई चीज़
जैसा
आपने फाइल भेजा
ये जो मैंने फाइल्स आपके व्हाट्सएप पे भेजी है 5-6 सारी, आप एक फोल्डर में वहाँ पे सेव करिए डेस्कटॉप पे 6 files, 2 data set and 1 PPT.
2 data sets, 1 PPT and 6 files. Okay, dear participant, I have already shared all the files shared by ma'am on our WhatsApp group of FCP. Please download it and upload in Jupyter Notebook.
You can download all the files, desktop, just copy paste, and then from the desktop upload into your Jupyter Notebook. Say for an example, this is your Jupyter Notebook. Go to upload. In upload, this is my data set, user data and social data network. I can open it this way. I can upload it. So this way you can upload. I'm already there, so I will not upload again. Again I can upload the Python files. All these 6 files will be there. I will open the 6 files here and upload all the files. So this way we can move forward. So you don't need to create any fresh notebook or anything, sketch in Jupyter Notebook. Just upload it and open it, and then I will tell you how to move forward with that. We will restart the kernel in the file, and then you will execute the program cell by cell. I'm sure you already know it, but again we will see that again.
Six files are there.
start with this random blocks where you don't need any kind of data set. You are randomly creating data, and then slowly steadily we will start to use some data set, and then later on the default or the stored data set, available data set into scikit. You get, if you get any error into library or something, you can do pip install in the version, or directly pip install, it will install the library also. In any case, if it doesn't work, open Google Colab and just copy paste the code, it will work. That is the last step. If you cannot run it, if you cannot solve the errors into Jupyter Notebook, just copy the code and cell by cell into the Google Colab. You can also store it or rename it according to your requirement.
व्हाट्सएप में इसको खोलूँ क्या कि उसमें दिखाओ सर
सर उसमें व्हाट्सएप खोल के आप डाउनलोड
कर सकते हैं मेल करने में दिक्कत हो रही है
क्या एरर आ रही है आपकी
फाइल ही है ना इसलिए
डाउनलोड करके डाउनलोड
वही करो
फोल्डर में फिर वहाँ से कॉपी पेस्ट आप डेस्कटॉप पे कर सकते हैं
हाँ वो खोलो
मैम आप कौन सा ले रहे हैं पहले?
Sir, I am taking random blocks of 40 samples. I have not like mentioned that 1, 2, 3, 4 into that. Check for this SVM example using random blocks of 40 samples. 40 evenly we have distributed, 20 for one and 20 for the another one. That way we can create a data set. So this is something which is randomly creating a data set, and then you are doing the classification. If you are getting any error, you can do the pip install library, whatever library it is mentioned there. Mostly it will not give you error. I think from 2-3 days, your Monday to you are doing coding, right? So I think all this library might have already stored in your desktops and machines.
वर्कशॉप वर्कशॉप इसमें सोशल ले लिया
But
आपने
PMT.show is not showing.
ये ले लो यूजर डाटा ले लो हमने 3D प्लॉट देखा
So I will run this. Have you opened this one now?
Yes. If I execute that one, the plot is not wrong.
Are you getting any error?
No error. It is executed. Yes. It is slow.
No problem. So this is like it shows you the like properly distributed data set. So this is the easiest example, yeah, like the first most easy one into 2D plane.
डिलीट कर देते डाउनलोड में देखो ना सर डाउनलोड में डाउनलोड में जाकर देखो डाउनलोड फोल्डर ये फोल्डर को ओपन किए तुमने नहीं सीधा डायरेक्ट वो फोल्डर से
here we are doing importing numpy library, matplotlib.pyplot library, plt. Then we are using obviously SVM, so we are calling that SVM library be here, so that will be from sklearn. You are importing SVM, so that will be from sklearn package import SVM. Dataset, you are creating random block dataset, you are creating random values into that, so you are calling that from sklearn.dataset import make underscore blocks. It will create random dataset over here. How many samples you are using, that you can mention in that. So here you can create 40 samples, so you are having x comma y. Make blocks, you are using sample, you change the value of the sample. This is 40 in our case, you can change to 10, 20, 30, 40, 100, 4000, whatever you wish to, and accordingly it depends what way complexity you want to portray into your data set. So 40 is like a visually, it's easy to understand. 40, 20, 20 set of, like you distinguish it later on. So you can change the values of into that. Then the random state 20 and the centers 2. Now you're using the perfect fit by using the kernel, linear kernel you're using over here. So CLF, you're doing the regularization. So CLF is equal to svm.svc, that is your support vector classifier. In the bracket, kernel is equal to linear kernels you're using. The value of C, as we have seen, there is a margin that you're permissible, that how much is permissible. You can change the value of C, and you can also play around with your code that what kind of output it is giving it to you. So you can change the value of C and check. Then you're trying to fit the model. So clf.fit x comma y. Then you're plotting the here by using the pyplotlib. By the scatter plot you want to plot. So you use plt.scatter, and all the values of x and all the values of y over here, you are using it, and plt.show, all the output will be available here into these two different sections. Default it is giving it to you. You change the value of your samples to maybe 20. Here it will give you some other less amount of data. You increase it to maybe 200. It will give you more concentrated data set, both the sides. Randomly it is creating, but it is creating concentrated into one side only, like just to trying to understand the separation by using hyperplaning this. So you use 20, 40, 200, 100, whatever samples, underscore samples value you change according to your wish. And this is the output you are getting. Everybody is getting this output? What error you are getting, sir? No error at all? Sir, you can do one thing. Sometimes it gives you the error. Go to the kernel, restart and clear the output of your kernel, sir, and then again run it. If you are getting blank output, then sir, go to this restart and kernel, here restart and clear the output, and again try it, sir. It should work. Kernel, restart and clear output, just click it and then again run it, it should give the output. What is the name of that error, sir? So there must be some punctuation, anything which you have deleted, sir? सर एक काम करिए, आप ना लाइन बाय लाइन ये कोड एक बार वेरीफाई करिए. आई एम जस्ट इंक्रीजिंग द लेंथ साइज ऑफ दिस. बाय मिस्टेक इफ यू हैव any even dot or comma or bracket, if you have missed, it give you error. Or if it is not working there, you can open the Google Colab and also try and do that also. Google Colab, sir. Mostly it should work, but if your system doesn't, if it is not upgraded or if it doesn't have good hardware, then it may happen. But this is a very small calculation, it should work. Not very heavy calculation. Kernel is equal to linear comma, capital C is equal to 1.
कॉपी पेस्ट में नहीं, वो उसमें चलेगा, उनमें चलेगा। बस चल यहाँ ब्लॉक कर देते हैं। वो फाइल में तो सब अपलोड कर देते हैं। 1 2 3 4 इसे कर लो एक बार। ये यूजर डाटा हो गया।
You can open your code into Notepad++ also, sir. वहाँ से भी आप कर सकते हैं. Is it working?
Yes.
What was the problem, sir?
We have created the kernel.
Okay. Sir, everybody is getting this output, sir?
Yes.
Sir, system error? सर आपका डाउनलोड
तो कर लिया, रन करना है ना इसको।
हाँ, आप अपलोड करके रन करिए, वेटिंग। यहाँ पे मैं वापस बता देती हूँ। आप यहाँ पे आए, ये ओपन हुआ है ना, इसके बाद आप अपलोड में जाइए।
अपलोड कर दिया मैडम।
ये अपलोड हो गया ना, इसके बाद उसी एक फाइल को आप यहाँ से जहाँ पे भी है ओपन कर दीजिए। इट विल ओपन लाइक दिस वन। फाइल पे डबल क्लिक करिए। ओपन हुआ? जितने मैंने आपको दिए हैं वो पूरे ओपन करिए, सारे के सारे ओपन करिए। और ये वाला फाइल जो है, नाम है इसका रैंडम ब्लॉक 40 सैंपल्स, ये ओपन करिए। 6 फाइल है, उसमें से ये वाला अभी के लिए आप ओपन करिए। ठीक है, SVM सपोर्ट वेक्टर मशीन एग्जांपल यूजिंग रैंडम ब्लॉक्स ऑफ 40 सैंपल्स, इसको आप ओपन करिए। ओपन करने के बाद सर यहाँ पे कर्नल में जाके रीस्टार्ट एंड क्लियर द आउटपुट करिए, फिर आप उसको सेट रन कर सकते हैं और आपको आउटपुट यहाँ पे दिख जाएंगे। रीस्टार्ट इसलिए कर रहे हैं हम कि आपकी सिस्टम के साथ वो अगर कोई एरर है तो आपको देगा वो, और वी कैन सॉल्व दैट।
रीस्टार्ट एंड रन ऑन। रीस्टार्ट एंड रन ऑन।
So this is your first output. Here it is, मैंने 200 लिया है, आप anything you can change into n underscore samples. If I am putting 40, it gives me this output. Now I want to predict, so I use new data 3,4, 5,6, print and predict the new data output. I want to see whether what kind of output it is giving it to me. So it is 0, 1 output it is giving. Next, if I want to regularize and if I want to see the plot, SVM plot into that, so I am using multiple lines over here. So here I am using AX is equal to, starting if we say CLF, here SVM.svc classifier kernel, and we are using the linear C is equal to 1000 dot fit x comma y. प्रीवियसली जो आपने रन किए हैं उसको कंसेक्यूटिवली वी विल गो फॉरवर्ड। स्कैटर फाइल आप यहाँ पे पेयर प्लॉट यहाँ पे आपको सॉरी यहाँ पे यूज कर रहे हैं, वी आर यूजिंग इट दैट वे। वी आर चेकिंग फॉर द ax is equal to plt dot gca, then x limit, y limit, x to y. We are also trying to plot the output. xs is equal to line space, right? Again here you are getting xx, yy, yx. Mesh grid output you want to plot over here. Next, decision underscore function xy dot reshape. Here next you are going to check the boundary, the decision boundary and margin you want to create. So you are creating the contour. ax.contour xs which you have created the grid to evaluate the model, xs comma yy comma z is equal to clf dot decision function where you are taking x and y, which is this one, and you are checking what are the style. ये आप चेंज कर सकते हैं अगर चेंज करके आपको प्लॉट करना है तो. So this is for your vector, this is for your hyperplane, this is for your support vector. It will give you the output. Next you are plotting again the scatter plot. Along with that you are taking this plots which is your hyperplane output and it is showing you the output this way. ठीक है, इसमें whatever your pi plot is being used, those functions, some of those functions are used. Whatever SVM fit model you are trying to use over here, that is also used into this. But here you are not doing a lot of data cleaning, data manipulation, processing. You are doing nothing. You are not doing feature engineering at all into this data set. This is smallest, easiest example that we can look forward for. इतना हो गया सबका? Run. है ना? So ये simple. अगर आपको SVM, if you don't want to show it into the theory, like just you plot one, one diagram, or you can take this figure as also, take this figure, put it into your PPT, this will also work. Just give the notification that this is a real output that you are getting from your Python file. So this is the first one. Second one, let's go forward with the actual algorithm. Again, restart and clear the output. Second file, open user underscore data CSV, user underscore data CSV file. So that is support vector machine using user underscore data dot CSV file. You can open it. See here I have mentioned a lot of comments. You can change the comments also. You can add on more comments into that also. You can enhance your data sheet or your notebook according to your understanding, right? कुछ और आपको डेटा आउटपुट में चाहिए तो वो भी आप एड ऑन उसमें कर सकते हैं. Fine. So everybody has opened this file? Yes. Which is, now we are using the data set. Previously it was the sample or random data we have created. Now if you have a data set, again you are uploading the data set by using, so here you are using the data pre-processing step, importing the library, again NumPy, Panda. These are the main libraries which each and every machine learning algorithm is going to use into all the codes. Then you are having a library of matplotlib to visualize your output. So here matplotlib.pyplot as MTP. Then you are having the data set which you are importing. Here you can change the data set according to your requirement. It means that you put the name you want to. अगर आपको लिखना है user underscore data, उसी को नीचे follow up में आप लेते हुए आइए. ठीक है, उसी को आप store. So whatever you are importing, that data set you rename it and you save it over here. So I saved that data set by using data underscore set. Next onward I will call the data set only into next process.
You have to mention the path of
Path, we have to mention the specific path or we directly upload.
सर 3 तरीके हैं, 3 से भी ज़्यादा है, बट अभी 3 देख लेते हैं. एक तो ये है कि आपका लोकल मशीन में फाइल है.
नहीं, वो इशू कहाँ से अपलोड करना है. अगर कोई डेटा है हमारे पास,
बट वो कहाँ है?
वो हमारे मैंने जुपिटर में रिमूव कर लिया है इससे.
आपका डेटा जुपिटर लोकल उसमें है क्या? लोकल होस्ट में है?
हाँ, लोकल होस्ट.
देन दिस इज द वे. लोकल होस्ट का अगर आपका डेस्कटॉप पे है, देन शेयर द पाथ. अगर आपका HTTP में कहीं पे है, उसका अलग मेथड है, वो उसके बाद में है. वो आप ही के पास है सर. यू ऑलरेडी हैव इट. You already have it. I think into
डेटा सेट अपनी जो भेजा ना,
maybe कैंसर डेटा सेट में शायद होगा वो. I don't exactly remember. It is already there. वो कैगल से आप डायरेक्ट इनपुट ले रहे हो उसमें. Okay, so here you are using the data set, uploading the data set, then you are taking the extracting the independent and dependent variable over here, that will be x and y, which is the index location dot ILOC that you are using. So from that location which is available here, you are taking some values into that, extracting some values, storing into X and Y. After that you are using the model, here you are using the model selection and train and test split. Again you are doing the train and test split. आप कर रहे हैं 75-25 splitting. So .25 यहाँ पे आपको मिल रहा है आउटपुट, मतलब आपका फिर 25% टेस्ट में जा रहा है, 75% आपका ट्रेनिंग में जा रहा है. So here you are splitting it. After that you are importing the standard scalar. After using it you are using the fit function, fit transform, and here you are checking for the output. So you are running it. After that you want to check the data set which you have stored. So this is the data set now you are getting after doing the pre-processing of the data. So you are having 400 rows and 5 columns. Now the index location ILOC that you are getting into that, depending what section, what chunk of data set you want to use, you change that values. ठीक है, वो आप इंडेक्स लोकेशन अपने हिसाब से आप चेंज कर दीजिए, तो वो ही सेक्शन का डेटा सेट आप उसमें यूज कर सकते हैं डिपेंडिंग ऑन योर रिक्वायरमेंट. सो हियर यू आर हैविंग 400 rows and 5 columns available. Now you are checking whatever test and train data you are having. The scalar output of test set would be available here. For the test available here. Then after you are using the fit function, you are using the kernel, which is the linear kernel you are using, as you can see over here. And after using that fit, you are using the classifier with y underscore prediction, classifier.predict x test you are checking. What is the output of prediction? Output you are getting it over here. This is the data predicted output you are checking. Now after that you are checking for the confusion matrix. So 4 elements that you are getting, 2 by 2 matrix, you are checking for the confusion matrix. What is the output of confusion matrix? And here you are getting 66 plus 24 will give you 90. So here you are getting output image, there are 90 correct predictions. 8 plus 2 is equal to 10 correct predictions here. Next you go forward with the output, checking for the output over here. So here the output red and green, you can change it in your this one, this two, red green. Change your colors for the plot, the output will be changed. This two, that is easy. Here green and red. List color map you can change according to your requirement, and you are getting the RGB set. You are getting the value which is 0 available here into the red section, the value which is 1 available into this particular section. Warning is fine. There's a computational warning is giving. That's fine. That's just a warning. Depending on your system and whatever versions you all have used into your system, sometimes it gives you warning. So that's not a problem. Though it is giving you warning, the output will be shown. Until and unless it's not giving you error, we are good. Fine. So warning is okay. The warning is not a big problem because it's a visualization doing computation. Sometimes it is giving you warning. Next, we are checking for the test result again. So this is the better version output you are getting compared to the previous one. ठीक है, जो हम बात कर रहे थे सॉफ्ट एंड हार्ड मार्जिन की, ये सॉफ्ट मार्जिन है आपका. ठीक है, यहाँ पे आपके बहुत रेड डेटा जो है वो आपके बहुत सारे रेड डेटा है वो इस साइड में है और बहुत सारे ग्रीन डेटा है वो रेड साइड में है. मतलब वो सॉफ्ट मार्जिन वो आपको प्रॉपरली डिस्टिंग्विश नहीं कर रहा है. बहुत सारे मिस क्लासिफिकेशन यहाँ पे हो रहा है. ठीक है, सो उसको यू आर ट्राइंग टू sort that problem, and here you are getting the output which is comparatively less amount of soft margin is available. So soft margin is something that permissible value of the misclassification, that is permissible, though it will give you good output into your application. So this is your second file execution. Next one we will go forward. अच्छा ये सबको output दे रहा है, इसका output सबको मिल रहा है. Warning is fine until and unless it's not giving you any output, we have a trouble. If it is giving you warning, that is okay, it is permissible in that. Next we will go forward with the third option. I have already done that, I guess. Yeah, again that is a user data. So I can do one thing. If I want to use from the Kaggle, I can directly use, this is the directory name, file name. If you want to directly import anything like any of the data set from the Kaggle, directly you can use this kind of, you can give the path and it will work. This if I don't want to use, I have to again read CSV and it will give me the output in that itself. So you can start executing one by one your cell in that and see the output. So this ilog that you have used into this, you can change the ilog values depending on your requirement. Okay, जब आप इंडेक्स लोकेशन का फर्स्ट एलिमेंट है वो आप कुछ भी नहीं दे रहे हो, मतलब वो all the data will be available into that, means all the data it will take, because you are not specifying anything in that. So checking for the X, which is estimated age and estimated salary, checking for the Y, independent and dependent variable you are checking separately, X and Y. You can use capital X, you can use capital Y, you can use capital X or small y, depending what you are comfortable to use the notification, the notation. Okay, so that's not a bigger deal into that. Maximum of the time it is like capital X and small y, majority of the people are using, developers are using. Okay, now we are using the splitting the data set for train and test. You are running that both. Again you are using the linear in that for the prediction. Store the value of confusion matrix into Cn. And you are getting the output, which is again 66, like the way we have checked into the previous one. Now this is the similar you have used for the previous. जो भी second file use किया था ये similar ही आप use कर रहे हो यहाँ पे. Only your visualization is changed. Fine. So here you are getting the output into this format and some data you have also changed. So this is the output you are getting for the third file, which is SVM. So everybody is getting up to this. Then we will proceed for the fourth file.
What is the name of this full file?
Only SVM.
Only SVM. This is I given.
That's in the WhatsApp, sir. I think I have shared it in the WhatsApp. You will get it.
जब तो अपलोड किया ना आपने उसमें से वो देखी ना सुपर वेक्टर मशीन कैसे दिखता होगा आपको.
एक आध डुप्लीकेट या स्किप भी हो सकता है.
सपोर्ट वेक्टर मशीन
Just support vector machines. That's the name of that file.
वो ट्री ओपन होगा सर, होम वाला या डाउनलोड वाला. हाँ उसको यूज.
चालू होता है
So everybody is getting output of this file last up to this.
इंस्टॉल करने के लिए
सर इन जनरल आई जस्ट वांट टू नो कि कौन कहाँ से थे सर आप लोग.
वन फ्रॉम चंद्रपुर मैनेजमेंट कॉलेज.
ओके आप भी
फ्रॉम नागपुर.
नागपुर में
जुड़ेला इंस्टीट्यूट ऑफ
JIT CS डिपार्टमेंट
CSC.
CSC. आप सर आपकी पता नहीं क्यों मुझे जानी पहचानी थोड़ी सी लग रही आई डोंट नो बट आप सर
नागपुर प्रियदर्शनी भगवती कॉलेज है.
ओके आप तो यहीं से लग रहे हैं मुझे. क्या बात कर रहे हैं. आप भी सर के साथ हैं. अच्छा आप मैम. ओके आप मैम. आप बड़े डेडिकेटेड है एकदम आराम से डेडिकेटली कर रहे हैं. सर आप कहाँ से हैं. सेम कॉलेज KDK. आप भी सर. आप सर प्रियदर्शनी. ओके सर आप.
Yes, come from Gujarat.
सर केम છો. आई एम ऑल्सो गुजराती. कौन सी कॉलेज से. पारुल. LD इंजीनियरिंग. LDRP गांधीनगर. ओके सर अभी ठीक लग रहा है नागपुर में. तीखा खाना तो खिला नहीं रहे आपको ऐसे. यू आर यूज्ड टू दैट साउजी वाउजी. ओके सर. आप सर प्रियदर्शनी. आप मैडम. मैडम आप कहाँ से. दिस कॉलेज ओनली. अभी यहीं से. ठीक है. So we are good up to this. चलिए we'll go forward with the next one that is for the breast cancer. Not sure. Yes, let's just restart this.
देखो उसमें मैंने डेटा भेजा हुआ है उसको तो डेटा पुल करते हैं.
Let's go forward with the cancer data, breast cancer data set. Now this data set is already available into sklearn. So many of the data set is available into sklearn. You can just directly call the data set and use that data set. Many medically like medical or disease diagnosed data sets are already available into this. There is also another one UCL library you can also check. There is also a lot of data are available. There is a lot of government libraries are available for different countries. Government libraries are also available. So those data set you can also use in this. So for this, if you have uploaded, we can start executing. Yeah. So here you are loading the data. That is the first. Second, you are exploring the data. Here you are checking for the features, that what number of features are available into your data set and what number of features you want to play around with into your data set to do some work, prediction or anything you want to work with. So here you are extracting some features and you can work around with that. So here you are around 30 features you are extracting. Sorry, 13 features you are extracting, not 30, I think it says 30. So 30 features that you are extracting over here. So many more than that. Next you are checking that what is the shape, I mean what is the number of rows and columns are available. So the total number of rows is 569, the columns are 30. So into 30 column, the meaning of column is 30 features are available into this. So the one feature, one column will be available into that. So into that, what many number of records you want to see? Here you want to see 0 to 5 only. So for 0 to 5, here you are taking the data set. Here you can print it. Check the 5 records for the feature set over here. So that set you are taking. Now let's look into the, so this one is, I think I have forgotten this one. You can mark down that and you can make it as comment. Go forward with the print cancer data set over here. So here it is. Now you can split the data set into how much they are splitting. They are splitting into 70-30 because the test size is 0.3. So you can also want to change it, you can change it to 0.25. So that will give you 75 and 25. So here it is 70-30, which is default, it is given to you here into this code. After that you are using the kernel, linear kernel you are using, and in that again you are doing some prediction. By prediction you are checking that you are doing the dot fit, trying to train the model using the training set over here, evaluating your data, and you are getting the accuracy which is 0.96. So 96% accuracy you are getting, which is good accuracy that you are getting into this data set, and by using the linear kernel over here into this particular code. So this is something you are getting. Now you got a classification rate of 96.49, which is almost like 50. So over here, so which is considered one of the very good output over here. Still, if you want to enhance that output, that you are using that output, you are using the precision as well as you are recalling, you are using the another one, right, matrix dot recalls for, if you are checking, you are getting 0.96, and the precision that you are getting, which is 0.98. So this is your like evaluation score that you are getting into your code itself. So this is number 4. I hope everybody is getting up to this clearly. Yes? Okay.
Ma'am, one question.
Yes, sir.
In sklearn, there are several libraries already available.
Yes, sir.
So data set, can we get the list of data set?
List of data set in what context, sir?
How many data sets are already available in that
Available into?
sklearn or in any of the package?
So you got to Google it. You can check the total number of the variety of data set available into sklearn. Directly give you the link.
Okay. There is no direct way to write a code or say simple line to get the list.
If somebody has made it, like many have made GitHub link and GitHub account, in a lot of repository people have made it already. If somebody have already made it, it will give you the GitHub link also. So you have to check whether you are getting it directly or you have to check for that thing also. Okay? Yes, so we'll go forward with the 5th option, which is the social network data set. So again, the 5th file that you can open, again you can restart, go to the kernel, restart and clear the output. This is a one of the like good habit. Any data set you download it from Kaggle or any Google repository or any GitHub repository, always try to check it into in your laptop or something like that. Many of the times, sometimes in even sklearn, as you have sir asked me, right, sklearn. So many a times they keep upgrading the class and the libraries. Sometimes they merge the libraries also. So whatever code you are using, first of all you have to restart and you have to check that whether the same classes and same libraries can be used or not used. That is something for your sake of saving the time, you can do it. Now let's go forward with the social network ads data set. You can import the library, you can check the head of that, you can check the shape of that. So there are 400 rows and 5 columns. So what kind of data, if you see the data set, again there will be categorical data and numerical data, right? So this is a mixture of categorical and numerical data. Gender is categorical data, age, estimated salary and purchased, 0 or 1, that is your 0 and 1, that is your binary data. Your age and estimated salary is your numerical data, right? So the moment you open your data set or check your head of your data set, just develop a habit to see how many number of columns are there, how many rows are there. Number of columns, it means what are the different kind of categories are there. It will give you more good idea into if you're doing feature engineering, right? Data processing, pre-processing, post-processing, it will give you the better idea if you know what data set characteristic is. Next you go over with the filter purpose for index location. You check, you use some code here, then you go forward with the splitting the data set into 75, 25. So here it gives you 0.25 and 75. So once you can do, whenever you are using next time, after I'll leave from there, next onwards, whenever you reuse your set, try to change the set 70, 30, 80, 20, something like that, and see that whether you are getting, add on couple of cells into that and do the comparative studies of what way it works better output or what way it gives you good accuracy, good output for the comparative studies. Here next you are using scaling using the standard scalar and normal distribution. You are using the kernel. Up till this now we have used the linear kernel. Here you are using the RBF. So into RBF we will see that what kind of output here we are getting into this code. In the print confusion matrix, again you are getting 64, 29, 3 and 4. I think that is a lesser value you are getting, 3 and 4. I think previously it was 8 and 2 that you are getting. Here you are getting 3 and 2. So after that you print the classification report. So when you say the report card, so this is another way to show the output. So that's why I hope in this code, in different code you are getting different ways of output. Sometimes you directly see the predictions, accuracy on that, or sometimes you can also directly go forward with the report card, that what report card is giving it to you. So here the accuracy wise you are getting the 0.93 as an accuracy that you are getting right over here. And F1 score, I think everybody is aware of F1 score and all, right? Recall and all, precision and all. So here you are getting the final report card into your output itself. So all these examples, 5 examples that we have taken, these are 2D examples, है ना? यहाँ पे कहीं पे 3D हमने check नहीं किया है. Final last code that we are having, that is for the 3D plot. If you want to see the plot into the 3D, that how the distribution is looking at into the 3D fashion, right? So you can see that. Now for the 3D, many of the tools like MATLAB and other tools are using the sigmoid function in the kernel wise, right? So let's see here what we have used into last one, which is 3D plot SVM non-linear distribution. Plot on SVM non-linear distribution. So if you're having non-linear SVM, how it would look like, how the plot will look like in 3D, how you can expand and contract that particular, how you can save that. So this we will see into this. Here you are using NumPy, Pandas, sklearn, pre-processing, standard scalar that you are using, regularization. Here you are using plotly dot graph underscore object as go, which is a new one you are using. Previously you were using only matplotlib. Here you are using plotly. So next we are having sklearn, SVM, CSV and linear CSV. Both the library you are importing over here. Then you are using the data from the Kaggle directly, and you want to see the output into that data itself. Now we are using Gaussian quantiles in this. You are giving. Sir, I think you check for if you are importing this library, plotly and all. If it is not imported properly or if it is not ever used into that machine, it may give you blank plot or it will not give you any plot at all. So here it is there, this one dot. You can also check it Google it, pip install plotly or anything like that. You check if you're getting what error you're getting, depending on that you can solve that error. Ma'am, you're lucky you're getting every output it. If any library is not identified, it may give you error. Again, you can restart the kernel and again check it. Pip install and that library. If it is pyplot or something like that. But also Google it, check it. Plotly. Yes. कुछ तो वर्क करेगा. सो कितने लोगों का वर्क कर रहा है, आउटपुट मिल रहा है, एक का मैम का मिल रहा है, बाकी में नहीं मिल रहा है आउटपुट, है ना. सो व्हाट वी कैन डू, वी कैन जस्ट चेक, or we can check on Google how to install Plotly in Jupyter Notebook. We will get some output here. So any library error, if it is giving it to you, so you have to use this. ठीक है, I'll just try to increase the size of this. Any package you want to, any library you want to install, just change the name of that library here, pip install, then the library. That is the first cell you have to start, you should start with, right? If you are getting downside error, the first would be that. So here, if for an example I have already installed Plotly, but I want to see that, so what I can do, I can use the plus sign, I can do this, I can check right. So if it is already installed, it will give you already requirement is fulfilled. So if the requirement is fulfilled, you don't need to redo it again and again. Every single time you are using it, you don't to repeat it. Once you have to install, that's it, right? So it is already, requirement is already satisfied. So any point of time, you already know this is not the library you have ever used. Always for the safer side, start with this cell, है ना? Pip install and your library. This is the only way, first of all. There is no other way that I am aware of. This is the only way we can go forward with. Fine. So this is your code. You are running the code here. Output is this. After that, हो गया? Like installed हो गया? सब कुछ आ गया? सर कॉन्ग्रेचुलेशन, बताओ तो सही. चलिए. So here you are using your gamma function here. Now the output look like this. If you see here in your cursor, you can check that whether your 3D output, what is the distribution of data, how the data distribution occurred. If you try to make it in 2D, it will look like this. Can you relate to the PPT picture now? There is a center circle and the outer side there will be a lot of data available. So if you see into 2D, this will look like this. If you see into 3D, this will look like this. So in between there will be the hyperplane. So you can see what are the data which are changed, and if you move the cursor, over here, it will give you exactly when the nearby, how the data is changing and what are the values which you are getting, the x, y and z value. So if you are using 3D, this way you can plot anything, the data you can take, and if you use 2D, use the kernel which is linear kernel and you are good to go. So this is your data output visualization for the Plotly. Now give me a second, we will plot it. Okay. Now you try to check this is your hyperplane. ठीक है? So previously, like the way we did into the first 40 samples, this is your one side of 20 samples, second side of 20 sample, and in between that you are getting hyperplane and the support vector. Similar way for the 3D, if you want to look into, this is your hyperplane that you are getting into that particular section. This is your hyperplane. Fine. So this is for the 3D non-linear data distribution. Right? For linear, you can go forward with the 2D. For linear 2D, and for linear 2D, non-linear, you can go forward with the 3D. This kind of model. Okay. So I think I am concluding this as of now, theory and everything. All the data that I have prepared for a month or so, that I have already shared it with you, right? And you can go forward with that data. And whatever references I have used at the last PPT, I have checked, I have given you the references. If you want the original, like I have used University of Austin PPT, I have used couple of portals, online portals, so everything is mentioned, most of the things are mentioned. So you can directly download the PPT, and those PPT are giving you more knowledge about the mathematical point of view. ठीक है, mathematical काफ़ी सारी चीज़ें उसमें available है. Fine then, yes sir, we can call it a day. You have any other requirement from my side, sir? Any other question you guys are having, so you can ask me. I hope everybody has executed all the 6 files successfully. Sir, वो pip file वाला आप सर ने किया ना, exactly आपको वैसे करना है. That is a moment of honor for me. So you can save my number. My name is Neema Ukani. My name is Neema Ukani, Neema-Ukani, Neema Ukani, and number is 8888 66 7485. Right, I hope that I have not bored you and we have learned something into this. I'm sure I'll do better next time in this. And if you have any other query, you can reach out to my number, and any other further requirement you have, please reach out to my number. This is the only number which has WhatsApp. I'm so bad into number management, so only one number from yours, and it will be like that one. Right? So any message you want to drop, if you want to get connected, you can just drop me your name and that. I will save your number, and then we can proceed. Sir, I own a company. So we have a startup with my husband over here, and that's New Intelligence. We are 1.5-year-old company, and we are sharing as much knowledge as possible to school children, to the PG, and as many people as possible. Yes, we are in Nagpur, in Trimurti Nagar. I'm working on industrial robotics, many different kinds of robotics, mobile robotics, warehouse robotics, drones. I'm working on a lot of automation systems. I'm working on DL, deep learning, data science, a lot of modules into that, computer vision, specifically into machine learning and all those algorithms, and trying to make it more simple as possible. So I'm working into multiple domains and trying to learn more. ठीक है सर.
Dear participant, anything you wish to ask? Okay. Thank you for such a energetic and knowledgeable session, ma'am. Thank you so much for that, and we hope that each and every participant surely get out of this the fruitful I am talking about. And in future, we are actually planned MOU. We are signed with Intelligence.
We already have signed them.
Yes, yes. We have already signed MOU, and I am talking about we are planned some for our student as well. Longer kind of session, not the shorter one.
Sure, sir.
Thank you so much.
Thank you so much.
From behalf of K.D.K College Management, authorities, and from the Department of IT, I'm thankful to you, ma'am, for such a wonderful session. And thank you participant for listening patiently, and for today we are calling off. Thank you so much.
Thank you so much.
One more thing, madam's husband is here. I apologize from my side.
No problem,
Not his present. So thank you so much, sir, for with us. Ukani sir, or
Ukani ma'am.
so thank you so much, sir, for being with us for the session. Thanks a lot.
I have shared the MCQ to ma'am.
Okay, sure.
So that procedure.
Okay, one more announcement, short announcement for you. At the end of the day, means last day, we are having one feedback session as well as exam session, right? So objective kind of means I'm asking you to prepare for objective kind of test.